Humans have discovered nearly 4,000 exoplanets throughout the universe, but only one of them supports life. It's not just a cosmic coincidence that life exists on Earth, but a complex interaction of scientific phenomena is turning it into reality. So our existence on Earth is not only a stroke of luck. One of the things which are making it possible is a protective bubble that spans the solar system, shielding the Earth from dangerous cosmic radiation emitted by supernovas, the universe's stellar explosions. Before we begin, welcome to Tech Unity, where I will share the latest scientific developments happening around us. Please subscribe to this channel and remember to click on the notification bell so that you will be notified every time I release a new video. Also, please give this video a big thumbs up. If you have any questions or concerns, leave some comments below. Let's go back to today's video. Before we go any further, let's take a look at the video and see what this massive bubble around our solar system is. At extremely high pressures and temperatures in the millions of degrees, deep within its core, the Sun generates energy by converting 4 hydrogen atoms into 1 helium atom. As a result of the conversion, photons and other subatomic particles, such as protons and electrons, are released, and they bounce around inside the Sun before making their way out. On average, the photons that warm our faces on a beautiful afternoon were created deep within the Sun 50,000 years ago, if not more. The solar wind is a stream of charged particles produced by the protons and electrons that leave the Sun every second. The Heliosphere is a sizable spherical bubble in interstellar space created by the solar wind. The Heliosphere extends beyond Neptune's orbit until it becomes diffuse and feeble enough to blend into the interstellar medium's background of rarefied hydrogen and helium gas, the space between the stars. Because the Sun, like all other stars, the Sun lives inside its own cocoon, blowing bubbles in the interstellar medium with its own solar or stellar winds. There must be an edge, a border between the interior and exterior of the bubble. The solar wind is contained within the bubble, as it is in all bubbles. While the interstellar wind blows outside of it, finding and pushing past the edge allows us to explore truly interstellar space. NASA studies the heliosphere to better understand the underlying physics of the space around us, which in turn provides knowledge about space throughout the universe and what makes planets livable. However, studying what lies outside the bubble ball is difficult because of its life-saving properties. It is difficult to estimate its size from within. Elena provided a cover as if you were in your home and wanted to see how it looked from the outside. She is a postdoctoral researcher at Johns Hopkins University Applied Physics Laboratory. She further adds that the only way to understand truly is to step outside and look far away from the Sun. Turn your head and imagine the heliosphere from the outside. When compared to the Milky Way as a whole, our solar system appears to be the size of a grain of rice floating in the middle of the Pacific. Despite this, the outer heliosphere is still so far away that it took the Voyager 1 and Voyager 2 spacecraft more than 40 years to sail from Earth to reach it. In the year 2012, Voyager 1, which took a more direct path through the solar system, was the first to depart into interstellar space, followed by Voyager 2 in 2018. They are now drifting out into space beyond our solar system, sending more data as they go. They are currently 13 billion and 11 billion miles away from Earth, respectively. Images of deep space show it to be completely covered in clouds of space dust and bright gas. However, scientists began to notice that the galactic space surrounding the Sun differed from this depiction, and the solar system appeared to be suspended in an absolute void. According to recent research, Earth is surrounded by a massive bubble that spans 1,000 light-years, and its edges are responsible for the formation of all surrounding young stars. Scientists investigated this bubble in a new study and discovered some intriguing new facts about how it promotes star formation. Surprisingly, the researchers discovered that all adjacent star-forming regions aligned perfectly with the local bubble surface. According to the study's lead author, Catherine Zucker of the Space Telescope Science Institute in Baltimore, the discovery was made entirely by chance. Oh, and if you're enjoying the video, make sure to like, comment, and subscribe to my channel below. And don't forget to click the bell to get up-to-date notifications. The scientists were able to recreate the chain of events that led to the formation and expansion of the local bubble by analyzing the movements of these young stars. By observing the movements of these rising stars, they discovered that 14 million years ago, a sequence of roughly 15 catastrophic star explosions known as supernova began to occur in the local bubbles, implying that they were moving due to the expansion of the bubble. Core supernova have been observed carving open voids in space, sucking up gas and dust as they expand outwards. So this appeared to be a plausible explanation for the local bubble. It was more challenging to piece together how and when because, for one thing, measuring the dimensions of space while inside it is difficult. It's even more difficult to quantify and avoid when dazzling stars and other cosmic objects surround you. Azuka and her colleagues used the most recent data to map the gas and young stars within 200 parsecs, or about 650 light-years, of the Sun. Gaia, a European Space Agency space-based observatory, has released data from an ongoing study to map the locations and movements of the stars in the Milky Way with unprecedented precision. When it first formed, the bubble was moving at about 60 miles per second, according to data collected by Gaia. The bubble is still expanding at a rate of 4 miles per second, and astronomers believe the solar system at its center because it is much older than 14 million years. According to Alvarez, an astronomer at the University of Vienna, the Sun was far away from the local bubble when the first supernova exploded. Around 5 million years ago, the Sun entered the local bubble and is now near the center. Because the Sun is now in the center of the local bubble, it implies that similar superbubbles may exist throughout the Milky Way. But what are the chances that our Sun will be in the middle of one? According to Zucker, astronomers compared the universe to Swiss cheese, with supernova blowing holes in the cheese and new stars forming around the holes left by dying stars. According to the researchers, more star-forming bubbles are expected to appear across the Milky Way. Alyssa Goodman, the study's author at the Center for Astrophysics, who invented GLUE, the data visualization program that helps the researchers put together their maps. She explained in a statement that the Sun would not be near the center of a massive bubble if they weren't common throughout the galaxy. According to NBC News, the local bubble is just what we happen to be in right now. We believe the Sun has passed through several superbubbles during its lifetime. According to the statement, more cosmic bubbles will be mapped in order to obtain a comprehensive 3D image of their shape, position, and size. Scientists will be able to piece together how these bubbles work as sanctuaries for stars, how and why the bubbles interact with one another, and how galaxies like the Milky Way develop over time by charting exactly where the bubbles lie in the vast expanse of space. We could say that humanity was extremely fortunate to have appeared on Earth as a species before the Sun flew into the local bubble. Or are these two occurrences the appearance of man and the presence of the Sun in a safe haven? The local bubble has somehow linked science, but we can be certain that the bright sky above our heads is due to the fact that we are literally in a vacuum of the local bubble. Countless stars would have been invisible if the space surrounding us was denser. That's all for today's video, and thanks for watching Tech Unity. If you liked it, make sure you give it a thumbs up and share it with your friends. And while you are here, click to watch one of these two videos appearing on your screen right now. We'll see you there.